Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. For years, we represented meaning in AI as a single point in space, a vector. But a single point of light, no matter how bright, can't illuminate the whole picture. Today, we'll discuss moving beyond that single point to a rich constellation of meaning. We'll introduce the Poly-Semantic vector framework, a multi-vector architecture designed to build machines that don't just calculate, but comprehend. The core problem with current architectures is what we call semantic collapse. We force every possible meaning of a concept, like the many meanings of the word bank, into a single vector. This creates a representation that is inherently ambiguous and context-poor. It's the reason why AI can seem brittle and struggle with nuance. To think, a machine must first be able to distinguish between these fundamental differences. The Poly-Semantic vector framework solves this by exploding that single point into a structured constellation. Instead of one vector for bank, we have a collection of them. A semantic vector for its dictionary meaning, a functional vector for its purpose, a causal vector for its effects, and so on. This allows the machine to hold multiple, even contradictory, truths about a concept simultaneously. Let's break down the polyvector for the concept of fire. The semantic vector, V_SIM, captures its scientific definition. The functional vector, V_FUN, knows its use as a tool. The causal vector, V_CO, understands what causes it and what it results in. The sensory vector, V_SIN, grounds it in the experience of sight and sound. And the affective vector, V_FF, grasps its dual emotional nature. Each vector is trained by a specialized model on specific data, giving it an expert understanding of its domain. Architecturally, the Poly-Semantic vector framework works like this. First, the vector generation layer, a factory of specialized AI models, creates each facet of the polyvector. These complete constellations are then stored in the polysemantic space, which acts as the machine's rich, long-term memory. Finally, the cognitive processor, the system's active mind, retrieves these constellations to perform its reasoning. This is the core of how the system thinks. It performs what we call facet reasoning. When it gets a query, it doesn't just grab the whole polyvector. First, it intelligently assigns attention weights to each facet based on the context. If you ask why, it pays more attention to the causal vector. It then creates a temporary, composite, task vector, a perfect blend of the faces needed to answer your specific question. This is how it achieves its remarkable contextual understanding. The opportunities this framework unlocks are immense, from AI that can explain its reasoning to systems that can make deep, causal inferences. But the path forward has its challenges. We need to create novel datasets to train these specialized vectors, manage the increased computational load, and solve the difficult research problem of ensuring the facets remain truly independent. These are the key challenges we must address on the road to true machine cognition. In conclusion, to build a thinking machine, we must move beyond reasoning about simple similarity. We need to build systems that understand causality, function, and even emotion. The Poly-Semantic vector framework provides a concrete architectural roadmap to get there. It's about giving our machines the ability to see the world not as a flat map, but as the rich, multidimensional, and deeply interconnected place it truly is. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.